Hi, welcome to Module 7. This is Part 3, and we're going to start out just going through the structure of any type of solar panel layout, and then we'll start talking about how you could do it too, how you can build your own small supply of power, because why not? So to start out, we have our home, and once again, the cells are in the module. So these are modules, and they are all together in an array. So this is in our array on the roof here. The array runs down into a regulator, which would be our offshoot for a battery system, which in my home, I do not have battery. Like I said, I go on the grid. But if I did, I would have a regulator so that I do not fry my batteries. And you're going to need one if you're going to build it yourself and try to store power. So you're going to have a regulator to make sure you don't fry your batteries. If there's too much power getting ready to pump into the batteries, it will be grounded. So you'll have a grounding line coming out of your regulator that will pump power into the ground. And then we have the inverter. So the inverter takes my direct current because the energy coming off of a solar panel is a DC current, and most homes are running on actuating currents, AC currents. So I need to turn my direct current, my DC, into an actuating current, an AC, so that I can utilize it for my home. From there, it goes into the meter, because mine does not have battery power, so I will run it into the meter, and it will run out onto the grid unless I need the power more. Then it will run from my meter directly into my home. So let's talk about building it yourself. This is a solar tractor. This is a little structure that I built. I use it around my yard to run electric tools on the far end. I have 2 acres and I have some animals, and so I sometimes need power on the far side of my yard to do things like repair the chicken coop and stuff. So I have built myself a small solar panel array when I'm not using it to either electrify a small chicken fence or do something out in the yard like run a power tool. I do use it to run a pretty little water feature for fun, because why not? We don't want mosquitoes, so make it look pretty. Here is the structure. So I just used a little LL Bean caddy so that I could drag it around the yard, and I made a mount on my frame of the LL Bean caddy, and I built a little module part for me to build a little box. In that box, I have this is a small battery, but normally this sucker actually runs into 2 deep cycle batteries that I have stored under my porch. But here's a little mini battery in case I'm on the far side. I can pull them off the deep cycle batteries and put them on my little mini 12-volt Hobby Lobby style battery. This is an inverter box / a panel control that allows me to plug in devices down below. So you can see my little 120 watt outlet here. And this is a control. This thing allows me to keep from frying my battery system. So the solar panel gets plugged into this, and then from here, I plug it into my inverter and battery system, so that each one can use power accordingly. But this is my control. This is what keeps it from frying this part of the system. It's also what it has the diode in it, so it also keeps the current from reversing at night and draining out the battery back into the panel. So it keeps everything from the circuit from moving backwards, but constantly moving forwards in one direction. Here is that little solar tractor right there. And that would be my little baby girl back in 2014. I now have a second baby girl, but there you go. So let's do a little bit of building it yourself based on some simple just lookups, textbook bits. So textbook has its own little version of how much it would cost, but I could actually argue that you could supply yourself quite a bit of power on a small scale without even needing to spend over $1,000. You could do it for about 800, 400, 300. If you're really doing something super tiny, you could do it for the cost of a solar backpack. I have a solar backpack. It works great. I use it to charge my laptop. So, it's all relative. So here is a little kit that you can buy, and this kit comes with a 100 watt monocrystalline power grid panel, and that kit is $300. This is a control regulator for $56. And then this sucker right here is my watt control inverter that allows me to plug things in and has 3 120 outlets. And this sucker is a more expensive one. This is just under $300. Here is a universal battery, and if you're going to use a car battery to do it, make sure that you are using either a deep cycle battery or a marine battery. Do one or the other. If you're going to hook them up to a car battery, which you can do that. It's totally an option, but this one is a universal battery, so it's not necessarily specifically for cars. It can be for many objects, including those children's Power Wheels, right? And here is an entire kit that you can buy, like on Home Depot, eBay, all those, with a mount system. And this sucker is $250. So you can buy a whole kit of a 100-watt panel for $250, and you just would need to buy yourself a $70 battery to go with that system. So it's not an expensive thing, and you can do it too. It's so simple. And you just hook it up to your inverter. And then out of your inverter or charge controller system, you then will hook up your battery, and there will be another bracket area that you can take the line out from, and you can hook up your actual power system. So you can just hook up a little outlet to it, a 120 outlet. There are a lot of pros and cons to solar panels. While the pros seem to be growing, since its early advent, there is still a lot of opposition and cons to solar panels. So solar electricity has two characteristics, but some of the big positives for it is that it's able to be done anywhere. And so I'm allowed to collect that light. Obviously, some parts of the world are better than others. One of the other big things about it that can be a downfall, other than the intermittent of solar panels, so if it's a cloudy day, I can't make electricity. The other big con is that it's an upfront cost. There's a lot of cost upfront, and while it pays itself back over time, I'm just starting to feel the payback from the solar panels that I put on my roof. And so it's all relative to what you're going to use. Another big one is that solar energy is only able to generate electricity during daylight hours. Therefore, I have to solve the biggest problem of them all, which is battery power. Battery power is expensive and costly and difficult, but it is changing and the technology is changing. And we'll see with the Tesla Powerwall, we have some big advancements coming. And so in the next 2-3 years, I'm going to be teaching my solar lesson. I'm going to be like, we've solved battery power. Solar is the answer. One can hope, right? So we're getting there. Another big con is that solar panel efficiency goes way down in places that are highly polluted. So areas like big cities where there is a high amount of pollution and debris and light pollution and all of those good things actually takes the efficiency down a lot, like down 20% to down to 20%. So it takes it down 80% total. And so it's a difficult one because solar panels are hard to get to work at maximum efficiency in places where the electricity is needed the most. Weather can affect solar panels. And so here is a little graphic that shows you EVAC tubes, so solar hot water heaters, advanced flat plate heaters, and on-glaze systems. And even though these are passive solar, they show you that the weather effects on these systems can be quite drastic in their ability to collect heat energy. The same rules apply for a solar panel. And then the other final one is location. Solar panels have to be used in the right location. If you live in a place where the weather is often clear, there isn't a lot of clouds, the doesn't need to be warm. It can be cold, and as long as it's not cloudy, it's a great location. But on the other hand, if I live in a place which is very cloudy and on call for in its weather conditions, it's tough to use. On that note, these are my cons. I'm actually not going to go through my pros to make a fourth video. You guys can read through the pros on your time, and if you have any questions, always post in discussion. Good luck working on photovoltaics. Let's hope to learn more about them future.